In this video, we'll be looking at Lesson 24, Correlation Coefficient, R. Two essential questions. One, what is correlation coefficient? And two, how can we calculate the correlation coefficient with our calculator? Correlation coefficient, which we use the letter R to represent, is the measure of linear strength of bivariate bi meaning two, variate variable. So when we talk about bivariate data, we're talking about ordered pairs, XY data. Measure of linear strength of bivariate data. Alright, here are some facts about correlation coefficient. Fact number one, the value of R is always going to be between -1 and +1, including those endpoints. A correlation of -1 means it's a perfect linear negative relationship, and +1 is a perfect linear positive. So if you could imagine a a set of points that had a slope of -1, that would give you an R of -1. You would have an R of -1 if you had points that were in a straight line with a negative slope. You would have an R of +1 if you had points that were in a straight line that had positive slope. R somewhere in between -1 and 1 would be number 2. R is unitless. That is, it's a raw number. It's not feet or inches or miles per gallon. It is a unitless number. Number 3, the variables must be quantitative. That is, you can't have categorical variables like color or gender or race. The variables must have a number attached to it, like age or weight or IQ or score on some test. Number 4, correlation coefficient makes no distinction between X and Y. That is, if you switched the X variable with the Y variable, you would find that R remains the same. Number 5, it is not resistant to outliers. One point that's a little astray in your data can greatly impact the correlation. And lastly, perhaps most importantly, it's the linear strength only. There can be a strong association between the two variables. They can be very closely related. It might be some sort of parabola, some quadratic relationship, but we only calculate r when the data appear in some linear form. It doesn't mean they're exactly in a straight line, but the form appears linear. How do we calculate r? Well, there is a formula that right now in your mathematical life would appear pretty crazy, but we're going to use the calculator entirely to do it. And in order to calculate r, we're first going to turn diagnostic on. In order to do that, you will hit the second key, followed by the 0 button, the number 0. You will see that says catalog when you look at the second of that. Then you will hit the X inverse key. It's on the left-hand side of your calculator. Then you'll scroll down. And then you will hit enter where it says diagnostic on. One word, they string it together, diagnostic on, you'll hit enter. Alright. After turning diagnostic on, you will enter the data in stat. And we have done this on numerous occasions for finding the equation of a line or the slope of a line. Then we will perform our linear regression. This is the stat calc 4 process. Stat calc and then 4. Once you perform this, you're going to get some output. Near the bottom of the screen, you're going to see two things. One will say r squared, and the bottom will say r. This r is what we're interested in. And 4. This r is the correlation coefficient. Now we will look at how to use our calculator to find some correlations. We will begin by turning diagnostic on. To do so, we hit the second key in the upper left. 0 is catalog. At this time, the alpha key is locked, so we can simply hit D, which is X inverse, to get us down to diagnostic, to the D's, and we will scroll down for diagnostic on. Scrolling down, you see diagnostic on. Once you're there, you hit enter. Now, you won't have to do this each time, but if you reset the calculator, you will have to. I could turn the calculator on and back off, and the diagnostic would still be on, but resetting the calculator, we'll have to redo that process. Now we will enter in our data. We're going to look at some perfectly linear data and see that that gives us an R of 1. So stat edit in list 1. If you have data points, you can go up to list 1 and hit clear. List 2 will hit clear. In list 1 we will enter 1 through 6. And in list 2 we're going to enter 2 through 12. All right. One of the fundamental concepts in the statistics is we will always look at the data. Before we go just jamming on keys from here, we're going to take a look at what this data looks like. In order to graph it, we will go to our y equals screen, clear any functions we have in there. We will turn our plot 1 on, hit enter. You can go second y equal to look at plot 1. The default is going to be the scatter plot, and that's what we're wanting to look at, a scatter plot. I can hit enter. Graph. Here you see the scatter plot, and here you can see these points in a straight line. If you hit zoom 9, that gives you the statistical zoom, which will have our screen nice and maximized. So we don't see all 4 quadrants, we just see the points we're interested in. And as you can see, these points are in a straight line. They have a y-intercept of 0 and a slope of 2. Alright, now what we want to do is find the R value. Since these points are in a perfectly straight line, we expect R to be 1. So, stat, calculate. 4 is our linear regression. Perhaps at this point, your screen just goes straight to where it says linreg. That's fine. If not, I can do these defaults. If I wanted to store the regression equation, I could store that in y1 and it would graph it automatically, but right now we're only interested in the correlation coefficient. So we go to calculate. All right, they give us the form y equals ax plus b. They tell us a is 2, that's the slope. And you notice with our data, as our x increases by 1, y increases by 2. The y-intercept is 0. It goes through the origin. Now we're interested in this value here. R is 1. As we predicted, it's perfectly in a straight line, so R is 1. Now let's look at some data that's that has a negative slope. In fact, where the R value will be -1. So back to stat, edit. Now leave your list 1 as 1 through 6. But in list 2, we're going to go in descending order, so we will make our first 12, then decreasing by 2 each time. All right, we will resume, zoom 9. And now you see that our points are again in a straight line, but they are moving in a downward direction. This line has a slope that is negative, and our R value is going to be -1 because it's in a perfectly straight line. Back to our home screen, second mode, stat, calculate 4. We see, again, this time our slope is -2. For every 1 we move to the right, we move 2 down. Our y-intercept was 14, but R is -1. Now we're going to, those cases are almost trivial because you will rarely see true data that is in a perfectly straight line, be it positive or negative. When we're looking at true data, we're going to have more scatter to it. So we're going to make some changes here. Going back to stat, then to edit. Let's change this. Let's leave 1 pairing with 12, but now let's pair 2 with 11. Let's pair 3 with 8.9. Let's pair 4 with 4.6. Let's pair 5 with, let's leave it right there paired with 4. And let's pair 6 with a 1.2. All right, now we will resume. Zoom 9. Okay, now you can see that the data is still certainly linear. That is, it's a linear form. It's not in a perfectly straight line. When we say linear in algebra, we mean it's in an exactly straight line. In statistics, we say that the data has a linear form. That is, it's generally in a straight pattern, not a perfectly straight line. So the data, it does have a linear form, but it's a little more scattered out than before. So we expect this R value. You can fall back on your experience from guessing in the R values a little while ago. And we know that this is going to be a value that is negative for sure because it's going downward from left to right. And it will be close to -1 because they're in a fairly tight line. So we will go to our home screen. And then again, we will regress. Stat, calculate 4. All right. So we see that our slope is still around -2 and our y-intercept is still near 14. And our R value is still very high. Our R value is -0.98. It's very close to 1. So while they were scattered, they were not significantly scattered. All right, that sums up how to find R using our calculator.